us look a little bit more at a battery. It consists of 3 elements: cathode, anode and electrolyte in between. Cathode is a positive, anode is a negative, and there is electrolyte. Ions are atoms that have lost or gained electrons. These are called ions, either one less than what in a neutral state, or it is negative charged, if it is one more positively charged, and these ions actually flow in the battery. So, there is a separator which separates out the positively charged cathode and negatively charged anode. So, in charging, electrons move through separator inside the battery to cathode, and then it gets positively charged. During discharge, the positive current will flow from here to here, electrons will flow from here to here. Okay. So, that is what happens. This is the way electrochemical battery goes. A lithium ion battery chemistry, itself there are large number of lithium ion battery chemistry. It has been evolving. There are at least 1, 2, 3, 6 major chemistries. The battery called LCO, lithium cobalt oxide. This is the main battery today which is used in cell phone. It is cobalt rich, and cobalt is a raw material which is extremely expensive, available only in a few countries, China, and there is a country called Chad in Africa, or another country, I am making a mistake, and that has a lot of cobalt. Cobalt is raw material which is not as easily found, but this is what the battery was used, good density, reliable battery. And then the battery came NMC, lithium manganese cobalt oxide. This is the battery which is most commonly used today, NMC. It gives you a good energy density, and NMC itself, it asks a question, how much of nickel, how much of manganese and how much of cobalt oxide. So, X, Y, Z, NMC 811 basically means 80% is nickel, 10% is manganese and 10% is cobalt dioxide. NMC 111 basically means equal quantity. As NMC 111 moves towards NMC 811, in between there is a 622, there is a 433, you will find more nickel and less of cobalt, which reduces the cost and increases the energy density. Today, after you have reached NMC 811, there are attempts to make it that add more nickel and less cobalt. That increases energy density, reduces cost. The other commonly used battery is NCA. In fact, NMC and NCA are more or less similar quality. We will get into it little later, but they are both more or less equal. NCA is used by Tesla for its batteries, very similar behavior, NMC and NCA. Now, you look at it, NCA has one advantage, it does not have cobalt, and therefore, can be less expensive. The disadvantage is it has lower number of cycles, NMC has higher number of cycles. So, Tesla still prefers it. You will say, why, if it is lower number of cycles, why is Tesla preferring it? Because Tesla has designed a large battery which lasts 600 kilometers, which means if it has only 1000 cycles, it is a 600,000 kilometers. Now, a vehicle in its life does not go more than 300, 400,000 cycles. So, 1000 cycles is more than enough. But if you have a 100 kilometer range battery, and if you have only 1000 cycles, that means 100,000 cycles, you have to keep on replacing maybe every alternate year. Then you want a 2000 cycles. So, that is the reason NMC will be preferred. There are one other battery called LFPO. LFP cathode, anode is graphite. All these had graphite anode. It is a battery which is safer than NMC. It used to be, it was a Chinese, I do not know the Chinese invention, but China dominated LFP and for a long time said this is the battery that we must use. Till 3.5 years back, it was figured out that LFP battery cannot go beyond 160 watt hour per kg. Remember that watt hour per kg that I talked about? So, it cannot go beyond 160 watt hour per kg, which basically means at 160 watt hour per kg, it costs, the material cost itself will be closer to $200 to $50. It cannot go in this direction. When China realized that, it decided to dump LFP battery, saying get rid of these factories, start making NMC batteries. It started only about 2.5 years back, but dumping can also mean that you can export the factory. So, if India does not understand this very simple thing that LFP's life is over, it will say, oh, give us the factory at low cost. Except you are taking the battery, factory which battery will have no future, because that has 150 watt hour per kg or no more. You already reached 300 watt hour kg. China has, it is China which is Chinese company CATL which has crossed 300 watt hour per kg, and tomorrow it will cross 400 watt hour kg. There's 150 watt hour kg will be 2.5 times more expensive. Who will buy that? But very often in India, we do not understand that. We will land up into trouble. There is other alternative. There is a alternative called NMC LTO. It is called LTO battery. It is actually a battery which has a lower energy density, but can discharge at a very high C rate and can withstand very high temperature. LTO battery, it is called commonly, it is called LTO battery. You can have a 10,000 cycles, but it is almost 2.5 times more expensive than NMC. Now, what do you do with 10,000 cycles or 15,000 cycles? And costly is about 2.5-3 times. And if you are going to put in a large upfront investment, and if your interest rate is not very low, you are stuck with the battery. So, in West where the interest rate is very low, it may still have life. In India, it has a very limited usage. There is also LFP LTO, not commonly used. There is something. These are the battery. The important thing is the battery that we have to really focus on is number 1 this and number 2 this. Both batteries are good. If you ask me to choose, I will not be able to, depends on the application. These are 2 batteries. Now, comparison, now just this is the same thing that I talked about. If I look at NMC, you can go 300 cycles, NCA also you can go 300 cycles, sorry 300 watt hour kg, 300 watt hour kg, whereas LFP is 120, 150, 60 to 100, 50 to 80. This is what determines everything. This is also brings down the cost. You can charge discharge at 0.5 C, 1 C, 1 C, 1 C. This you can charge discharge little faster, 2 C, but again what is the use? You are limited by the energy density. Life cycle, this had a slightly higher life cycle, but this also 2000 are there now, and with silica you are looking at 8000 cycles. So, this is also fairly good. Cell temperature has to be 55 degrees centigrade. LFP is safer. Now, we must understand why is it safer. It has less energy density. Anything which is less energy density will be safer than anything with higher energy density. So, you have to actually use higher energy density because it will cost low, less weight, and make it safe. Cell cost, of course, you are seeing $100 already on this. Okay. If you go look at only safety, I will say NMC LTO is extremely safe, but energy density is only 80 watt hour per kg. What do you do? Cost is extremely high. So, you must understand for what usage you are going to use what. China, for example, declared a policy that by 2020 all vehicle batteries should be 350 watt hour per kg. They are not, they are going to fall behind, they will not reach 350, but they have reached 300, that is the important thing. They are saying if it is less than 350, you will not provide subsidy. I think they are modifying that. This is the way you push technology. They declared it about 3.5 years back. India declared we will use LFP, which is less than 150, because it did not understand at all. I will say we will keep them on par. China realized that it has to get rid of LFP. LFP cannot go above 150. Everybody is so used to LFP. Chinese company will dump LFP in China. They say, well, you won't get subsidy if you use it. And since subsidy still plays a major role, it was able to force Chinese company to move towards NMC and NCA. This is the way Chinese policies are done. We may have our differences with China, we may not like China, but at least they are clear that they want to technologically advance. So, now by and large there is a consensus in the world that NMC, NCA, but for a few years there was a lot of lack of the confusion not there. Well, for example, MNR in India still says you have to use only LFP battery. How this decision was taken, how did the Chinese influence them, I leave it. But the decision today is you can only use LFP. We are making things, solar packs with NMC battery, this you cannot use it. So, what are the 8 asks of a battery? First, as I talked to you, high specific energy or gravitational energy density. Number 2, high specific power. Can I run at 2C, 2.5C, 3C at times, discharge at least, even charge at times. So, specific power, specific energy. Affordable price, very important, very important. Long life, can I get more number of cycles? Price and life cycles have to go together. We want affordable price, low price for reasonably good number of cycles. Fifth is safety, of course, it has to be safe, we will make it safe. But you must remember that the brand name of lithium ion is safe as opposed to lead acid and all that. When used correctly, if you do a bad design, it will be unsafe. When used correctly, the brand name is safe. Wide operating temperature. You want to be able to operate in low temperature, cold temperature at 45, 48. This is a difficult one, but this is our ask. I am telling you what are the asks. 6th one. 7th one, low toxicity. It is not bad, but it has to be disposed of well. And then fast charging. Fast charging is actually related to the C rate that I talked about earlier. Normally, lithium battery should be charged at 1C or lower, but can I charge occasionally fast charge? Now, specific kind of battery you can, otherwise you impact the life very badly. So, these are the 8 asks. Finally, a very important ask is also low self discharge. Shouldn't I charge it, come back after 3 days, 20% gone, that is no good. Now, fortunately, lithium ion batteries have decent self life. There is a very interesting way things are represented. A battery chemistry is represented by a kind of a 6 axis curve. 6 axis curve, specific energy, specific power, safety, performance, lifespan and cost. Lifespan, number of cycles, cost, performance, to some extent C rate, safety, total power that you can draw, specific energy. This, so if you look at it, this LCO battery used in cell phones is very good specific energy, low cost, ideal would have been lower, power moderate, not very good, large power, but then so C rate is low, but that does not matter because cell phone draws very little current. Safety, good safety, performance, overall performance of the battery is good, and lifespan is decent. If compared to this, I look at a battery called NMC. NMC is the, if you look at it, it is a more even, it is all, it is a moving towards hexagon. So, the weakness of it is, it has enhanced safety, specific power has gone up, it can do better than that, cost is roughly the same, lifespan has gone up. So, overall this has is a slightly, specific energy has gone up significantly. If I look at LMO, there was another chemistry, and today sometime LMO is mixed with NFC, its cost is lower, specific energy, specific power, safety, lifespan is also lower. So, when you mix things, you have to really worry about it. LFP, the specific energy is where it loses. Look at this. Once again, this is much higher, this is bad. Cost is decent, slightly higher because of the lower this thing. Power, it can do better than even NMC, safety, it is better than NMC, performance not that great, lifespan better than NMC, but it is this is the most important parameter. These and cost are related. So, this is the angle that you have to really worry about. Look at NCA, almost similar to NMC, except if you see cost is even lower, but lifespan is less, should have shown up more, lifespan is less. Safety somewhat less, but it is okay. LTO on the other hand, very low specific energy, very high cost. This is not cost low, sorry. I think I may be making mistake unless cost wise is very bad. Yeah, this tells you how good it is. Yeah, so cost is so sorry, even in NCA the cost is higher than. So, how good, it is a goodness in all this. So, this is a higher cost, lifespan is good, very good, specific power also can be very good, performance can be very good, safety can be very good. So, this is a very good diagram. I have taken this from a website called Battery University. In fact, much of the material in this chapter has been taken from the Battery University. It is a good description of these things. So, to sum up, battery chemistries for electric vehicles for some time to come is NMC graphite and NCA graphite. I will look at the future battery in a short while. Gravitational energy density is touching 300 watt hour per kg, cost is going down to 100 watt hour, $100 per kilowatt hour. New cells will have higher energy density and therefore lower costs. Well, there are assignments that I am giving you, very simple assignment, true or false, you have to just keep marking that, and then we will come to batteries in future.